Today we are going to add in-air controls to our drivable car. This guide will show you step by step how to add rotation control and move your vehicle while midair. We will be using a chaos vehicle. If you want to build a chaos vehicle from scratch, check out the tutorial we did in the description below. Anyway, let's get into it. Before we can add in-air controls, we first need the ability to tell whether we are on the ground. To do this, we are going to use a line trace. A line trace is just drawing a line from one location to another and returning whether we collide with anything. It's a bit more complicated than that, but for our purposes, that's all we need to know. Our line trace will start at our car's body and draw downwards towards the ground. If we hit something with our line trace, we will assume we are on the ground. To implement the line trace, open up your vehicle's blueprint. In Event Tick, add a line trace by channel node. The node takes a start and end location. The start position will be our vehicle mesh's world position. So drag your mesh into the blueprint graph and then add a get world position node. Our end position will be the mesh's world location minus an arbitrary length along the z-axis. I'm setting our example to subtract a vector with values 0, 0, and 250. This approach ensures the line trace is always pointed straight down. On the line trace node, make sure Ignore Self is ticked to true. Set the draw debug type to 1 frame. Let's hit play and see the results. While playing, hit F8 to detach from the player controller, and then you can move the camera into our vehicle to see the line. It's just like how we set it up. It starts at the origin of our vehicle's mesh and draws downward. The line trace ignores our car and hits the ground beneath us. The red square shows where we're hitting the ground. The green line shows where our line trace would continue after the hit. Now back to our vehicle blueprint. Let's print the return value node and see a change when we jump in the air. Very cool. So now we know that when the line trace hits something, it returns true, and when it doesn't, it returns false. You might have to fiddle with the length of the line trace to a distance that works for you. I have found making the line trace a bit longer than the distance to the ground is effective. Now that we know when we are off the ground, we can add inputs for our in-air control. First, let's store the result of our line trace in a local variable named onGround and set its default value to true. We can also get rid of the print statement. We don't need it anymore. In Unreal, new inputs are added by first creating an input action object. That object is then added into an input action map. Let's make 2 input action objects, one for pitching the car up and down, and one for rotating it left and right. You can put your input actions anywhere in your project, but I am going to use the same location the vehicle template uses. Go to Vehicle Template, Input, Actions folder. There are already a bunch of input actions here. Right-click to pull up the context menu, go to Input, then select Input Action. I'm going to name it IA for Input Action _ Pitch Car. Open it up and let's set its value type to Axis 1D Float. Now let's make another input action for rotating left and right. Let's name it IA _ Rotate Car and give it a 1D axis float as well. Now we just have to add our input actions to our input mapping. If you're using a chaos vehicle, you are probably using IMC _ default. It's located in Vehicle Template Input. Open up your mapping and you'll find inside that each input action is mapped to a physical button. To add IA Pitch Car, press the plus button at the top of the list. It's kind of annoying, but you then need to scroll all the way down to the newly created empty mapping. Set it to IA Pitch Car, then set its input to the physical inputs you would like to associate with it. These could be buttons on the keyboard, the mouse, or a controller. I'm going to set it to the mouse y-axis and the controller right stick y-axis. Let's repeat the process for IA Rotate Car and set its inputs to the mouse and controller x-axis. Once done, make sure to save and let's jump back to our vehicle's blueprint. Right-click and search for Rotate. Our IA Rotate Car event should now appear. IA Pitch Car should also be available. Let's focus just on rotation for now. We'll set up pitch later. Just to confirm everything is wired up correctly, let's print a string whenever we move the mouse on the x-axis. If it isn't printing for you, go back and watch the previous part. Something is misconfigured. Okay, now that we are printing, let's update it to only print when we are in the air. Like before, we can use an if statement based on the on-ground bool, and only print if it returns false. Very cool. So now we are just handling our input when off the ground. We're getting close. Let's try to do some actual rotating. To start, drag your mesh into the blueprint. It's what we're going to be rotating. Drag off the mesh node and search for Add Local Rotation. We only care about the Z rotation, so right-click the delta rotation input and select Split Struct Pin. Now we can pass in a value for just Z rotation. Let's also set teleport to true. We want to rotate without physics impacting our rotation speed. We are then going to multiply the action value by the getWorld delta seconds. GetWorld delta seconds returns the number of seconds since the last frame. Let's multiply that by the input action and pass it into the yaw value. Let's see what happens. Not quite what we were expecting. One annoying thing I noticed is that when we rotate with the mouse, it is also moving the camera around. We need to turn that off. If you're using a chaos vehicle, go to the parent class BP_P_vehicle, and inside that blueprint, there is an event called IA Look Around. We want to turn off look around when in the air. We define the on-ground variable in the child class, so let's redefine it in the BPP vehicle class, and then add an if statement to only look around if on-ground is true. Interestingly, when we defined on-ground in BPP vehicle, it caused Unreal to rename our on-ground variable in our car to on-ground 0. This is because the variable can't be declared in the parent and child class, so the parent version takes precedent, and Unreal renames the child class variable. This isn't a big deal. We just need to replace references to on-ground 0 with references to on-ground. The easiest way to do this is to right-click on on-ground 0 and select Find References by Name. It will display Find Results. If you click on a result, the editor will focus in on that instance. Go ahead and replace all the references. Once that's done, let's try it out. We are moving the camera when on the ground, but when we are in the air, the camera isn't moving at all. The car is barely rotating, so let's add a multiplier to the yaw rotation. I'm going to name it rotation speed. Set it to 100 and let's see what happens. Very sweet, we are rotating, but the camera's moving again. It's not moving because our input anymore, but because there's an event in our parent vehicle class that is trying to rotate the camera to point at the back of our mesh. Let's update it so we don't move the camera when we are in the air. We will make the camera point towards the trajectory our car is moving. Go to BP_P_vehicle. Inside there is an interps to original rotation event. Let's add an if on ground conditional to it, so it only applies when the on ground is true. Next, let's make the camera point towards the direction our car is moving when on ground is false. To calculate that, let's get the actor location, pull off the actor's location node, and search for Find Look at Rotation. Our actor's location will be the starting position. We then want to get a point in front of our car along its trajectory. To calculate that, get your mesh component, drag off it, and search for Get Component Velocity. We are then going to normalize that value so it has a length of 1 and multiply it by 1200 so it's 1200 units long. We then add that value to our actor's location to get a point 1200 units in front of our car. That value then becomes our look at rotation target. I'll also add a debug sphere node at the target location so that you can see where our target is located. Then just get your back spring arm, drag off it, and add a set world rotation node. Finally, let's feed our look at rotation into it. I'm going to organize these nodes a bit, then let's compile and check it out. Our car's camera still moves and readjusts when we are on the ground. In the air, our camera follows our car's trajectory, and we can spin it. You can also see the white sphere, which is our rotation's target location. Now let's apply the same logic for pitch. This should go a lot faster. Go back to your vehicle blueprint and copy-paste the nodes from IA Rotate Car. We just need to update the Add Local Rotation to change pitch instead of yaw. Our vehicle is flipping, but it is turning the camera weird again. To fix this, go to your vehicle's blueprint and look at the spring arm settings. Make sure that inherent yaw, pitch, and roll are checked. Try again and it should work okay. Our car is spinning, but I also want to be able to push the car around in the air. In most games, after you jump, you can move the character in air to control where they land. To do that, let's add the ability to push our vehicle left and right. Here's an example of it working already. So how are we doing this? Well, you could make new input actions for pushing, but we already have input set up for steering. If we look at IA steering, it is already a 1D axis float. Inside our mapping context, steering is already triggered using the A and D keys. If we go to the parent vehicle class, BPP vehicle, we see that steering is already set up for us. Now what's kind of cool is we can extend the steering input action in our child class as well. So let's go to our vehicle child class, right click, and search for IA steering. Now the parent event and child event will handle steering input. To push right and left, we want to push right and left relative to our camera, not the car's rotation. To do that, let's grab our back camera, drag off it, and search for Get Right Vector. This gives us the vector perpendicular to our camera's forward vector. Let's normalize it to be safe, and then multiply it by our action value. Our action value can be between -1 for left and 1 for right. So when we multiply the vector by the action value, we are changing its sign, either negative for left or positive for right. Our vector has a max length of 1, so let's multiply it by a constant float value. For my vehicle, I'm using 50,000. This value will vary based on the mass of your vehicle, so you may have to play around with it. Okay, now vector represents the magnitude and direction of the impulse we are going to apply to our vehicle. To actually apply the impulse, grab your mesh node, drag off it, and search for Add Impulse. Then just pass the vector into the impulse parameter. We only want to apply this when in the air, so like we've done before, let's only apply the impulse when on ground is false. Compile and let's see it moving. Cool, now we can push the car and rotate it. I think that brings us to the end. Please subscribe if you found this tutorial helpful. Thanks, bye.